Welcome back to another video. Today we are going to learn about the working of this RFID, and at the last of the video we will also see how to interface this LCD display with this RFID. So let's get into the video. Now RFID stands for radio frequency identification, and this is the wireless technology which allows two devices to communicate and transfer data with each other without making a physical contact between them. And the entire RFID system consists of two devices. The first one is the RFID reader and the second one is the RFID tag. Now the tag is usually connected to the object which is to be identified and authenticated by the RFID reader. So in this project we are going to use this model. This is RFID reader and we have two kinds of tags. First one is in this form and another in the card form. And this is the internal structure of the RFID tag consisting of copper traces. So if you flash the light behind the card and look from the top, you can observe these tiny traces of the antenna coil which are running all across the card. And at the bottom of the card we have this tiny microchip here, which is the brain of this RFID tag, and it is connected to all these copper traces. Now there are two types of tags in RFID. First one is active tag, which relies on its own battery for powering its chip, and it creates the magnetic field using its battery. Second one is a passive tag. It doesn't have its own battery. It relies on the magnetic field which is generated by the RFID reader. So the tag that we are using in this video is a passive tag. Now the RFID is operated mainly in three types of frequency bands. The first one is a low frequency, which ranges from 125 to 134 kilohertz. And if the tag and the reader are within 10 centimeters of the range, they can communicate perfectly fine. The second one is a high frequency, which is exactly 13.56 megahertz, and it ranges up to 100 centimeters. The third one is the ultra high frequency, which ranges from 860 to 916 megahertz, but its range is quite high, 100 to 150 centimeters. Now see, on this RFID reader, there is an antenna coil present only on this portion. So when the current is passed through the coil of the reader, it creates a magnetic field around it. And when the tag is brought closer to it, what happens? A current also induces in the coil of the tag because of the electromagnetic induction. So in this way, the tag and the reader are electromagnetically coupled. Now let's see how is the data actually transferred between the reader and the tag. Now inside the RFID tag, there is a transistor which acts as a switch, and this transistor is connected in parallel with a resistor, and this resistor is called the electrical load in context of RFID. Now let's say the tag wants to send this series of ones and zeros of data to the reader. So for sending 1, the transistor will turn on, it means the switch is closed. So the resistor is added to the circuit and the tag will try to draw more current, and as a result it will extract more energy from the magnetic field which is being generated by the reader. Similarly, for sending 0, the resistor is disconnected from the circuit and the current requirement of the tag will be reduced, and consequently the energy requirement will also be reduced. So these rapid changes in the tag's power consumption causes a tiny measurable voltage drops in the reader's own antenna coil. So according to the transformer theory, any changes in the electrical load in the coil of the tag, which is on the secondary side, is reflected back, and we can measure it as a change in impedance in the coil of the reader, which is on the primary side. And this is what we call load modulation. Now in the setup, I have interfaced the LCD screen and the RFID reader with Arduino, and I am going to print the UID of this tag. So UID stands for unique identification. You can consider it as a secret key. So each tag has its own UID. This tag has its UID. Similarly, this one will have different UID from this one. So when I will scan the tag over the reader, you will see that the UID will be printed. Okay. Now we are importing some of the libraries in our program like SPI, MFRC522. So basically the chip that we are using on our RFID reader is this one, right? Which is operating on a high frequency, 13.56 megahertz. And this is for LCD display. And we are defining the pins for RFID reader, SS and the RST pin. And these are the initializations of RFID and LCD objects. Now this is the placeholder for authorized UID. So initially we are defining the dummy UID. After scanning the tag on the reader, whatever actual UID we will get on the serial monitor, we need to enter that UID here. And in the setup function, we are initializing the SPI communication, I2C communication and the reader. And in the loop function, we are waiting until the new RFID card is present, basically the RFID tag, and reading the card data. After scanning the UID, we are printing that on the serial monitor so that we could enter that UID here in the placeholder. And we are comparing the scanned UID and the authorized UID for accessing or denying the grant. And based on the result that we will get from the scanning, access granted or access denied, we are updating the LCD based on that. And at the last, we are stopping reading to avoid the multiple triggers from one scan. Because sometimes what happens, the reader may scan 2 or more cards. So we are avoiding that situation here. So how much did you find this video helpful? Tell me in the comment section, and you can also drop your queries in the comments. And don't forget to like, share and subscribe to my channel, and thanks for watching.